Hi everyone, in this video we are going to discuss this result. So we have a matrix space XD and they have mentioned we have a sequence Xn. So that sequence is a Cauchy sequence. We have to prove Xn is convergent if and only if Xn has a convergent subsequence. So let us write the given information. What is the given information? That Xn is a Cauchy sequence. We have a Cauchy sequence Xn. So this is a given information and we have to prove Xn is convergent if and only if Xn has a convergent subsequence. So you know that if in a statement we have if and only if thing, we have to prove in both ways. That means first of all we have to assume Xn is convergent, we have to prove it has convergent subsequence, and we have to prove the converse part also. So let us start to prove the first part. Assume that Xn is convergent. So if any sequence is convergent, it converges to some point and converges to X. So this is the given information, right? And what we have to prove? We have to prove that Xn has a convergent subsequence. Let me mention, to prove that Xn has convergent subsequence. Okay, this thing we have to prove. So we are familiar with the epsilon definition of convergent sequence. So let us start with one epsilon. So I am going to take one epsilon. Let epsilon greater than 0 be given. Okay, so this thing we have assumed that Xn is convergent and converges to X. So let us use it. We have what we have, that sequence Xn converges to X. I am sure you are familiar with the definition of convergent sequence. What is it? For given epsilon greater than 0, but epsilon we have already assumed, so let us write for above epsilon greater than 0. Therefore, for above epsilon greater than 0, there exists, this is simply definition of convergent sequence, there exists n belongs to set of natural number such that, okay, so let us write here. Okay, let us write. What I should write? D of x and x, distance between x and x. So we have a matrix space XD, so same D I am using here, less than epsilon for all n greater than or equal to capital N. Simply I use the definition of convergent sequence and we could write this one. So using given information, we got this statement number 1. What we have to prove? We have to prove that it has convergent subsequence. If the original sequence is convergent, it has a convergent subsequence. This thing we have to prove. What will I do? I will take any arbitrary subsequence. Okay, let us take some subsequence. Let x and k be any subsequence of xn. So I have taken any subsequence, arbitrary subsequence, and now I am going to prove that that subsequence will converge to the same point X. Okay, so let us start to do any arbitrary subsequence. I will prove x and k converges to X. See, from 1 what we have distance between xn and x less than epsilon, and this inequality is true for all n greater than or equal to capital N. That means if you take any suffix which is greater than capital N, definitely this inequality will be true for that suffix. Okay, so therefore if I take any nk, let me mention for nk, okay, obviously it is greater than or equal to k, and if I take this k greater than or equal to capital N, let us see what will happen. What I want to say, if our small n greater than or equal to capital N, this is true. If you take any small m, if you take m is greater than or equal to capital N, you will get d of xmk less than epsilon. If I take any k here, k greater than or equal to capital N, we will get d of xnk less than epsilon. Similarly, I am taking a suffix nk. So from 1 what can I write? D of xnk x less than epsilon for all this nk greater than or equal to capital N. I have already written. So I should mention from 1. Okay, if any suffix is greater than capital N, definitely this one will be true. So from 1 I got this one, and this is definition of convergent sequence. Therefore, I can write x and k converges to x. So, in this way we proved that if the original sequence xn is convergent and converges to x, its subsequence is also convergent and will converge to the same point. So, half part of this theorem we have proved. So, let us go for its converse part. You can make a screenshot of it, then I will go for the converse part. So, let us prove the converse part. Let me mention conversely. So, we assume that, so now we assume that xn has convergent subsequence. Xn has convergent subsequence. Okay. So, let us say xn, okay, xnk, say xnk. So, now we have xn has a convergent subsequence and I am calling it as xnk, and it will converge to some point, and xnk converges to some point p. Okay. So, this is a given thing, that means this part we have assumed, and we have to prove xn is convergent. To prove that xn is convergent, so what will I do? See, here we are going to use the definition of convergent sequence. So, obviously I should start the proof by taking one epsilon, which is a positive real number. So, let us take epsilon. Let epsilon greater than 0 be given. Okay. So, right now we have two informations. The first information is that xnk converges to p, and the second information is xn is the Cauchy sequence. This is so much important thing, they are given to us, but still till we have not used it. So, let us use. So, epsilon greater than 0 we have taken. Okay. So, this is the important information I am going to use. We have xn is Cauchy. So, this is a Cauchy sequence. Okay. So, we can use the definition of Cauchy sequence. What is the definition of Cauchy sequence? For given epsilon greater than 0, here epsilon we have already taken. So, let us write for above epsilon greater than 0. Therefore, for above epsilon greater than 0, there exists n belongs to set of natural number such that okay, I am simply using the definition of Cauchy sequence, which is d of xn xm less than epsilon for all n greater than or equal to capital N. Okay. So, this is definition of Cauchy sequence. So, here what we see, the distance between two terms of a sequence xn and xm is less than epsilon. Epsilon means what? Very small positive real number. So, just for adjustment I can replace epsilon by 2. Okay. So, epsilon represents a very small positive real number and epsilon by 2 having a same meaning. So, that is why we can just for adjustment, okay, I am doing here epsilon by 2. So, let us call it as equation or inequality number 3. So, the first information I use. So, right now we have the second information also, that xnk converges to p. So, let me write, we have that xnk converges to p. So, this information I am going to use. So, therefore, by definition, for above epsilon greater than 0, there exists a natural number n. But see, natural number n we have already taken. So, let me call it as n1, right, and this is n2, such that by definition of convergent sequence we can write d of xnk p less than epsilon for all n greater than or equal to n2. So, here also for adjustment I am going to write epsilon by 2. So, now we have these two inequalities. But the problem is that this is true for n1 and the second is true for n2. Getting? So, it will work for capital N1, all n greater than or equal to n1, which is one fixed natural number. And the second inequality is true for n greater than or equal to n2, which is another natural number. It can be another natural number. So, what will I do? I will choose maximum of n1 and n2, then 3 and 4 will be true for that n. Okay, so let me write, let n0 is equal to maximum of n1 and n2, then both of them will work, then 3 and 4 will work for this n naught. That's it. Okay. See, there is no more space to write, just make a screenshot of it. So let us focus on our target again. Okay, what we have to prove? We have to prove that xn is convergent. So here I am going to prove it will converge to the same point P. Okay, here again I am going to use the definition of convergent sequence. So what we have to prove? We have to prove that d of xn p less than epsilon, then we can say that xn converges to p. So let us start with this d of xn p and we will try to prove it is less than epsilon. Okay, so let us start. Let me remove this one. So consider d of xn p. Okay, do you remember triangle inequality? So this is one of the definition of metric. D of AB less than or equal to d of AC plus d of CB. Okay, if you add one point C here, you will get this type of triangle inequality. Distance between A and B is less than or equal to, if you take any point C, distance between A and C plus distance between C and B. So this is triangle inequality. For triangle inequality, we need to have 3 points. But right now we have just two, xn and p. I will take xn k, that is a third point. So by triangle inequality, what can I write here? Let me write triangle inequality less than or equal to d of xn k plus d of xn k p. I have taken this third point xn k, right? So by, let me mention, by triangle inequality. Okay, so d of xn less than epsilon by 2. Okay, so if you have any 2 points, the distance is less than epsilon by 2, just this condition should satisfy. So here also we can write this is less than epsilon by 2, but that condition, that n and nk. So obviously nk is greater than or equal to k. Ready? Greater than or equal to k, and I am assuming both of them are greater than or equal to n naught. Here n is also greater than or equal to n naught. Okay, why I am writing n naught? We have already written n1 here, but see, n1 and n2, we have taken the maximum of them, and 3 and 4 will work for this n naught. So that's why I am writing in this way. Epsilon by 2 plus d of xn p, we have written somewhere, yes, it is less than epsilon by 2. So I should write this is also less than epsilon by 2. N greater nk I should write, getting? So this is nk we have, so here also I should write nk. So nk is greater than or equal to k and k is greater than or equal to n naught. So let me mention from 3 and 4, right? Epsilon by 2 plus epsilon by 2, epsilon. So what we get? Therefore d of xn p less than epsilon for all n, also we have got less than or greater than or equal to n naught. So this is definition of convergent sequence, and we can say that xn converges to p. So in this way we proved that sequence xn is also convergent. So in this way we proved the theorem, Thurl theorem, getting? So theorem says if the given sequence is Cauchy, then it is convergent if and only if it has a convergent subsequence. So both parts we have proved here. Just make a screenshot of it, then we will stop. Thank you. See you.